Thanks, Teresa. Good morning, everyone. All right, so let's start with the why we care about determining growth stages. Our goal at the end of the day in crop production is maximizing our yield potential, right? And a fraction of that yield is determined at multiple growth stages. And at pretty much each of these growth stages, the crop plant is dealing with the unique scenarios, various biotic, abiotic stresses, insect pressure, disease pressure, drought, too much water. And if we are not careful about, dealing with these problems early in the growing season, we might lose that yield potential. And once we lose it, we cannot recover it. So that's why it's very critical to understand these crop growth stages and then gear our management towards some of those issues that are happening throughout the growing season, right? So we don't end up trying to be behind that game of maximizing our yield potential. How do we determine some of these growth stages? So again, the way we stage a plant, it's at a plant level. Out in the field, we have a lot of plants, right? So that means we probably will have an overlap of stages out in the field. And our rule of thumb is that we are calling a field at a given growth stage when at least 50% of the plants have reached a particular stage. All right. So we recommend folks to go out and scout at multiple spots within a field and then assess a growth stage based on if we have had 50% of plants at that growth stage. What are the different methods? They all are crop specific. We will talk more about those here in a minute. But the main key here is that there are multiple methods out there. For every crop plant, there are multiple ways to stage. As an example here, you can see for a corn plant, we can stage it by determining the plant height, number of total leaves, or number of leaves with a collar. And we'll come back to which one is the most commonly used. The key point here is that we ought to be using a method that's commonly used in research, because that's where a lot of information comes from. So something to keep in mind. Let's start by looking at a crop that's out there in the field actively growing, right? It's been a couple of beautiful days here. A lot of these growth stages are driven by temperature, amount of heat, and wheat is progressing nicely. In wheat, the most commonly used scale is what we call Feek's scale system, which is divided into these different growth stages, starting with tillering, where you can see the plant starts with emergence and then it starts tillering, goes into winter dormancy and starts coming back. And now we are in this stem elongation phase where we are seeing pretty much, actual stem nodes come above the ground level, and we'll cover a couple of these important stages. And then this eventually leads into reproductive phases, starting with heading, flowering, and then maturity, which are down the road. Yield formation, again, as I mentioned before, is very important and something I want you all to be thinking about, right? The yield formation does not occur towards the end of the growing season, more so in these grass crop species like wheat, and we will also cover corn, and unlike soybeans. Here you can see that our first yield component is number of effective tillers per unit area, and they have already been determined in our crop this year, right? But if you look at number of kernels per head, and there are other components too, number of spikelets per spike and things like that, they have already been determined. We cannot see it, but it's already happened. That's why it's very critical to pay attention, right? The actual number of kernels will be determined when the plant flowers, and same with kernel weight. But you can see again, some of these components are being determined before we see them, and makes it very important to take care of some of these management problems early in the growing season. In terms of important growth stages, Feek 6 is one of the really important one. We all also call it jointing stage. And as you can see in a couple of these pictures, that's where you can feel this first node above the soil surface. It's sticking towards the bottom of the plant. If you are out there, probably mostly fields in South and Central Michigan are already at this stage. And this one, again, as you can see here, it's already a cutoff for split end application. The growing point is above ground, right? Any traffic can create an injury to a wheat plant at this stage. And this is also a cutoff stage for some herbicides, as you can see in this chart that I copied from Weed Control Guide. And you can see herbicides like 2,4-D, Clarity, I believe ALS inhibitors and group 4 herbicides are in this category. There are still some that can be used, as an example, Harmony, but keeping an eye on these growth stages is very critical. Another important one, growth stage in wheat is when it starts producing the flag leaf, as you can see here in Feeks 8, and then Feeks 9 is the flag leaf is completely out. And these stages are very critical because flag leaf contributes more than 50% towards the total yield potential of your plant. So based on any presence and severity of a foliar disease, this might be a stage where you might want to think about applying a fungicide to protect that flag leaf. More importantly, flowering, which is called as Feeks 10.5.1, is really critical. That's again the start of reproductive phase in wheat. And this is where fungicide application to protect against fusarium head blight, also called scab, is very important to minimize any issues we might get with worm and things like that. The window is relatively short. Once the plant is a start of flowering, you can see in a couple of pictures here, anthers protruding out, it's a 5 to 7 day window. So hitting that window is very critical in terms of management. All right, let's move on to corn here. So as I said before, here, the most commonly used method is what we call a leaf collar method, where for V stages, we are counting number of leaves with a visible collar, as you can see in this picture. And it's a clear separation between your leaf blade and leaf sheath. And the way we count this is we start with that rounded leaf at the bottom. So that does get counted in the most commonly used methods. So that's your leaf 1. You can see in the picture leaf 2, leaf 3, all these 3 have a leaf collar, while these other 3 leaves do not have a leaf collar. So this plant would be a V3 plant, not a V4 or V5 plant, right? And again, this chart shows you the whole phenological development of a corn plant, right? Starting with V stages, as we were talking, and some of these early V stages are very critical in terms of proper uniform stand establishment. A corn plant does care about uniformity of emergence. So whatever we can do to maximize that is very critical. And then we go into these reproductive stages that I will come back to. One of the important point here, again, going back to the yield components, is early on, we do expect that we are already determining number of plants, right? Number of ears per plant. And you can see also in this triangle on yield components that the ears per unit area is your first yield component, and that's already determined early, and we all can expect that. But look at these other components, number of rows on a ear as well as number of kernels per row. They are already being determined between V6 and V12. So relatively early in that growing season, right? So that's why we have to be careful in terms of minimizing any stresses early in the growing season in a corn plant, right? And then the kernel weight is our final yield component, and that is being determined relatively late in the growing season. Let's look at a couple of critical stages. So V6 is one of the main ones. Just like wheat, in corn, this is where the growing point is coming above ground. So before this stage, the growing point is protected below the soil surface. So a frost event might have a minimal damage on that growing point and plant, right? In terms of management, the nutrient demand is increasing for the plant. So any side dress nitrogen applications, this is a good stage to go ahead with that. And this stage is also a cutoff for a couple of herbicides. You can see 2,4-D is less than 8 inches plant, which is probably a V3, V4 plant, up to V6 for Liberty, and up to V8 for glyphosate herbicides. And V8 is a little bit hard to determine just by counting number of collars, because as you all probably know, by that stage, we are already starting to lose a couple of these bottom leaves. So how do we stage that plant, right? This is where we recommend using this splitting the stalk method, where we are pretty much cutting at the bottom through the middle of the stalk, as you can see in a couple of these pictures. And we are trying to identify node number 6 on that stalk. How do we do that? You can see in a couple of these pictures, the first 4 nodes are pretty much sort of lumped together. They are hard to separate. But then between node 4 and 5, we have about half an inch or so. And then between 5 and 6, we have about an inch or so. So it's using this method, you can identify where node number 5 and 6 is and identify that leaf collar number 5 or 6, and then count from there to get to V9, V10, and whatever growth stage. So again, something critical in terms of staging late V plant. R1 is probably the most critical stage in a corn plant. That's where the silks are visible outside of the husk cover, as you can see in a couple of these pictures. And this stage is very important. Again, this is where the pollination is happening, right? That's where we have to make sure that there is a synchrony between silking and pollen shed from the tassel, right? And it's very sensitive to stresses. And this is where the actual number of kernels are being determined on that ear, right? Because of this sensitivity, irrigation, probably, if that's a possibility, this is a good stage to target that irrigation. And fungicide application is another important management tool here, especially if we have had issues with the mycotoxins, high worm levels. Protecting that silk by applying fungicide at this stage, in addition to if there is any presence and severity of a foliar disease like tar spot, probably an important stage to do those applications. Next one, dent or R5 is another critical stage. This is where we actually start seeing the kernel progress towards accumulation of starch. As you can see in this progression of milk line, it starts from the top of the ear at 1/4 milk line. We are less than 50% dry matter. So any stress can still impact our yield a lot, right? And as we progress towards this 3/4 milk line, now we are almost 90% yield. In terms of management against silage growers, the good idea is to target this about half milk line. But that's again a rule of thumb, and we want to know the whole plant moisture to actually go ahead with that harvest timing. The final stage here is the black layer, as you can see in a couple of these kernels at the bottom, where this black layer formation sort of shows the final stage physiological maturity. Yield is determined at this point. So if we get a frost even late in the season, there is not going to be an impact on yield. There might be an impact on dry down, right? So moisture content at this phase is still around 30% or so, and we want to bring it down below 20 to maximize profits, right? And this is a tool that we do recommend for growers to sort of estimate phenology for their field based on their location, the planting time, and the hybrid maturity they are selecting. And this tool spits out the time to silk and time to black layer, and a very useful tool if you're trying to estimate where your plants are, estimating when R1 is going to happen for your management decisions as well. There's an instructional video that I put a link here that is very useful if you want to know more about this tool. All right, moving on to our final crop, soybeans, which is a little bit different, right? Both wheat and corn are a grass plant. This is a legume, right? So here we determine V stages. You all probably know this by counting number of open trifoliates. So the picture I'm showing here, you can see we have 2 trifoliates. So this is a V2 plant, right? Relatively easy. This plant is different than wheat and corn because it's day length sensitive. So in terms of start of reproductive stages, that does play a role. We generally have a rule of thumb that by summer solstice, June 21st, the plant only starts flowering after that. But based on planting time and the maturity group we are selecting, it can flower before that as well. And we determine our stages by counting number of uppermost main stem nodes with a fully developed leaf. And you might ask, what's a fully developed leaf? For us, a leaf is fully developed, as you can see in this image, when the leaf above it is open, because that leaf is not contributing much. So we start with the fully developed and not just the open leaf from the top. And that's the most commonly used method out there. This chart shows you various V stages transitioning into R stages, and we'll come back to some of these critical ones. But again, the point here in terms of yield formation is, unlike both wheat and corn, here you can see some of these yield components, number of pods per plant, seeds per pod, are happening relatively late in the growing season, happening when you actually see them, right? Unlike both wheat and corn. So again, something to keep in mind as we progress through the growing season for a bean plant. In terms of critical stages, again, R1 is a critical one here. Not as important as for a corn plant, but still this stage is critical. That's where either R1 is when we are beginning to flower at any node on the plant. R2 is when we see a flower at one of the two uppermost nodes, as I explained before. And flowering in soybean plant occurs for a long time, unlike corn. So again, there is more window of opportunity, even if we abort, if we lose some flowers. In terms of management, again, for white mold, this is probably a good starting point for a fungicide application, right? And if there is any foliar disease, something to think about. There are multiple herbicide cutoffs here. You can see R1 up to R1 for Liberty, up to R2 for Enlist, and through, so going through the growth stage R2 for glyphosate. And that information can be found out again in our weed control guide. In terms of probably the most critical stage in beans is R3, what we call beginning pod development. When you see that small little pod at one of the four nodes on the main stem. And again, this visual shows you how to do the counting, right? We are starting with our node 1 is a fully developed leaf over here, right? That has an open leaf above it. So that's node 0. And then we count 1, 2, 3, 4. And we are looking for this small little pod on one of these nodes, as you can see in this picture. And other stages are determined using the same counting method. In terms of management, again, this is a very critical stage for stress, just like R1 in corn. So if we have ability to irrigate, this is probably a good starting point there. And for fungicide application, no later than R3 for white mold, something to keep in mind. Other growth stages you can see here, these are the seed development stages when the seed, the actual bean starts forming and goes through these different stages. R7 is when it's reaching its maximum yield for the most part. For the most part, at these growth stages, management-wise, we are already a little too late. So there isn't much we want to do at these stages, something to keep in mind. So again, to wrap it up, these stages are very critical to know yield is being formed as the plant is progressing. We have to keep up with the management. Scouting is very important for all of these things, right? So I have listed a lot of resources here that are on our website, or a couple of these visual guides from University of Wisconsin on both corn, soybean, and wheat are really a good tool to have while we are out there scouting. And I'll stop there.
All righty. Well, thank you so much, Manny, again for that wonderful presentation. And now we will go ahead and field any questions that are out there. Feel free to put any additional questions in the chat. The first question that I had coming in is, how long for Manny? How long does pollination take as far in a normal year or a wet year versus a dry year? How long is that pollination duration?
Yeah, that's a good one, Phil. So in normal conditions, at a plant level, I think once the plant starts pollinating, it's about 7 days. But since we have variability within a field, I think the typical rule of thumb is that for a given field, the plants are shedding pollen for about 14 days or so. So That's in normal conditions. Any stress during that time is gonna make it shorter. So anything that we're talking drought, we are talking about any heat stress, that will shorten that window compared to if it's cool and wet conditions that can extend that window. So that's the pollen shed. But then the silk is out there and needs to be receptive to the incoming pollen. And I think that for a given plant, I think it's about that same, that it's 5 to 7 days. For a field, it's about 10 days or so in total. And again, drought can shorten that too. So this is where the synchronization between the pollen shed and the silk being receptive is very critical. And any water stress is a negative, can lead to low pollination, less fertilization, and less number of actual kernels, right? Even though those potential we are already determined V6 to V12 if we were on top of it, right? And we can have up to 600, there's a potential up to 1,000, we can still get 600 or so kernels, but any issues with pollination can bring that number even lower.
Alrighty. Thanks, Manny. The next question was still along corn lines. It actually wasn't in the chat for everyone, but the question was, as far as nitrogen application for corn, the most critical timing is making sure it's available at what stage?
Yeah, that's a good one. I'm not sure if Kurt is on the call. He would know more. But again, I think the idea is that the plant nitrogen demand increases as it goes through the its V stages, right? I think typically V6 is what we have recommended folks, compared to if you put everything up front, and if you get a big rain event, the chance of losing that is high, relatively high, right? So if the more you delay it, I think the peak might be even close to R1 or so. I think by R1, the plant might have taken only like 40 to 50%. I think that is sort of, again, don't quote me on this, but that's sort of what I would think. So there is still plenty that plant still needs to absorb, but we cannot go back to the field, for too late because of the equipment restrictions and things like that, right? We might cause injury to the plant, breakage, things like that. So around V6 or so is, I think, where the split end, I think, can go in. We have this new technology. It's still coming through short stature corn, where the plant height is not as tall. And I think this is one of the potential benefit with the technology like that we can access these plants relatively late in the growing season. So potentially we can delay that and application even further.
Okay. Another question then is, we know how important stands are, especially in soybeans. When is the best stage to take those stand counts in soybeans? So
yeah,
you would know.
Yeah, that's a good one. So again, it's a relative to me, a comparison as well. Stand is important, right? Our goal is, we were talking about maximizing yield potential. To maximize yield potential, we need to have a good canopy out there. What I call, like, that's our factory, is having all the leaf area out there, right? For that to happen, now we need enough well-distributed stand, right? In a soybean crop, it is important, but actually in corn, it's more important to have a very uniform stand. So if we do a comparison, let's start with soybeans. Early season is important. We typically go around V2 stage or so, when the plant has two trifoliate leaves, and do your stand count. What's a good number to maximize that canopy leaf area, maximize light? It's relatively low. It's actually around 60,000 to 70,000 plants. As long as they're well distributed, we are going to be okay. A soybean stand can look a little ugly early in the season, but a plant is able to branch out and compensate for any relative loss in stand, is what I'm getting to. Compared to, on the corn side, plant is not able to compensate. Typically, corn plant doesn't tiller, typically has only 1 ear, so it's not able to compensate. So if we have holes in our stand, that's very critical to go in there, V1 or V2, assess your stand. And if there are any issues, if we are below thresholds, and there are multiple charts out there to look at that, doing something about it is more important. On the soybean side, unless it's really poor, we recommend people not to worry too much, because the plant is going to branch out and able to compensate. And actually, if you have had issues on the soybean side, to me it's more critical to know what's the stand at the before harvest. right? Because that's what we are harvesting, and there can be attrition during that growing season as well. So again, even though critical on the soybean side, the thresholds are low, few gaps are okay, but on the corn side, we have to be much more careful.
Alrighty. Thank you. I think that's all the questions that I had actually that were in the chat and otherwise. And so if there's any other expertise that would like to make statements, or any other specialists that would like to make any observations or comments today?
Teresa, I think Mark has something for Jeff here.
Oh, I thought he was just making a comment about our wonderful
okay.
weather
Okay.
not being cooperative.
Okay, that's a good one. Yeah.
Because he said, yeah, Jeff's, this weather seems to be the same as you have been describing recently, with conditions that seem good for crop production, but we just have the very small window of opportunity for field work. Thanks for explaining this frustrating reality. I think it was just an observation.
Yeah, and again, I was thinking about what I had said, and it's a tough one for most. Unfortunately, for most of us, I think we are looking at some more delays, especially in the next week. But the important thing is there will be areas that are missed or get very much less rainfall probably, and in those spots, the opportunities will still be there. Like they have been in the last week. We've seen some of that happen here just in the last few days.
And I
Okay.
think Mike has something in here. I don't know if he's on. I think he has an article put in here about soybean planting operations. Mike, are you on?
I am, Manny. Thank you. Yeah, this is a situation being in Michigan. These planting, wet weather at planting is pretty common in May. And that's why Manny and I have always been promoting lately early planting if we can, so we can get some beans in the ground before we get into this situation. Well, unfortunately, we may not have got as many in as we'd like. But what I would encourage growers to do is to be patient. Be patient. Don't mud the crop in. Sidewalk compaction can be a much bigger issue throughout the season. So please be careful with that. I had written an article back in 2022 when we had a similar situation, and the title of it is Be Patient but Prudent. And that link that Manny mentioned is in there in the chat. So please click on that. It's a really long link, but it's a really good article, I believe, for this situation. So be patient but prudent. What do I mean by prudent? Think about your planting capacity. Manny's got some really strong data, and some of his colleagues across the country, that we don't have to plant with precision planters. Soybeans can be planted with a box drill or an air seeder. So this might be perhaps the time to maximize planting capacity. If you can tend multiple pieces of equipment, this might be the time to think about how to do that. The other way that you can extend planting capacity, of course, is plant it longer through the day. So that's going to mean maybe more labor and things like that. So just be thinking about what you can do to increase your planting capacity. The other thing I would say that's in that article is to maybe understand your planting capacity. And in that article, there's a nice formula for doing that. Basically, if a 40-foot air seeder with a central fill, and we're assuming that we can plant maybe close to 20 acres an hour with that type of equipment. It's just nice to know what your capacity is, what you can get done. The last thing I would mention is when you're trying to identify the fields. Jeff was right, spot on. Coarser textured soils are going to be ready to go. We all know that. But the one thing I would say is that rains are spotty. And so fields that we thought might be ready to go or wouldn't be ready to go might be ready to go if the rains miss them. So just be aware that rains can be spotty, and that maybe even some of our heavier textured soils, may have avoided the rain and may be ready to go. So just survey your fields, rank them in order of planting priority, and that's about all I've got. Thanks.
Very good comments, Mike. I totally agree with you. I think on the soybean side, we talked about this 2 weeks ago, uniform seed placement is not as critical. It's good, but now is the time, as Mike was saying, get your box drill out, because again, delayed planting, we know there is a penalty there. And this year, I wish we had more acres in the field, but the weather just doesn't seem to cooperate. So awesome. And there's a lot of comments in the chat box about Mike's retirement. I think we all should maybe have a applause here for Mike. I think this is his last day, Mike, if that's right, right?
It is, Manny, my last day
Yeah,
after
congrats.
35 years.
And I would echo that. Yes, our legend is retiring. And so, yes, this is our last time that we can, at least publicly in this arena, thank him for all his wonderful work and contributions to our soybean people. Thank you, Michael.
Thank you, Teresa. Good to have you on board as a partner. Wish we could have worked together a little bit longer.
Thank you. All right. I think there was one more chat out there about something about alfalfa weevil. I think this is directed toward Chris. DeFonso about
yes.
alfalfa weevil. You get
Yep.
a comment?
Yeah, so I'm getting a few questions about alfalfa weevil, a few fields. They're a little bit early this year. I mean, they're cold tolerant, so they've probably been egg laying through April into May, but we're first starting to see larvae. So if I was going into a field, first I would target stands that are a couple years old because they're kind of lazy and they overwinter on edges and then they'll move back into the same fields. Then I would use your sweep net just to see what's going on as a crude way of doing that and check for the tiny larvae. Phil was making fun of me earlier because I carry a little ruler with me where I go. And also a lot of my field books have a ruler on the inside of the page, and that's so I don't exaggerate sizes of things that I'm finding, like some people I know, Phil Case being one of them. So they would be very tiny right now. If you got a little penny, I carry a penny, you'd have a couple of larvae on Lincoln's head at that point, and they'd be green with a black head. They'd be pretty small. Once you start to detect them, then I'd switch over to looking at tips. And don't just glaze over the whole field. Your eye will be drawn to the dramatic damage, but pick those stems and rate how many tips have feeding. And the kind of, not the threshold, but the action level is if you have, I have to remember this, if you have short alfalfa that's 6 inches, you want to recheck that in a week. If you've got like 25% tip feeding, if you're up to 50% in 9-inch alfalfa, that would be, now you'd want to switch over and do larval counts, 75% in 12-inch alfalfa. And if you're at 16-inch, that'd be like 100%. And that's when you would switch over to the final thing, which is to do an actual count. And that would mean picking up stems very carefully and whopping them into a bucket, or I use my sweep net and just shake them really vigorously. And let's say you do, what you want is a total of 100 stems, but you can do 10 times 10 stems essentially. And then you're going to count larvae per stem. And that's going to be what you make your decision on. So right now, if you're at 9-inch height and you have less than 1 per stem, but it's, oh, sorry, if you're at 1 or just a little over 1 per stem, that would be a spray threshold. If you're at 12-inch stand height, then you're looking at 2 per stem or more. And that you could spray, maybe do an early cut. But if you're in 16-inch alfalfa and if you're over like 4 per stem, I would just harvest that. I would early cut that. We're not at that, of course. We're at the very beginning of tip feeding at this point. So I think what I'll do is I'll type up a little Fonz facts today and I'll send that out. So you don't have to, remember my counts that I just gave you.
Chris, a lot of times that alfalfa is going to be harvested when it's 28 inches and taller. So when you talk about those heights, 16 inches is giving up quite a bit of yield. I'm not sure as far as the timing on the difference between 16 and 28, but it may be a week or more. So you're still suggesting to harvest in that situation?
But that's more than 4 per stem.
Yeah, that's a lot of feeding.
So, I mean,
versus spraying.
Yeah, because remember, alfalfa weevils should be controlled by biological control. So yes, you may spray and give up some yield, but then you also would have given up all that biocontrol that's out there. If you spray, you're just going to wipe out whatever's there as far as biological control. And that could affect you the next year. Because remember, alfalfa weevils, they don't move very far. So once you get an infestation in a field, it's kind of your local infestation. And so they're going to over summer and overwinter in the tree lines and the ditch banks, whatever's close by. And that biocontrol that accumulates should stay with that.
Are there any
And
other
when I say
questions?
over, that could mean 16 inch or greater. So say your stand is at 20 inches and you don't know what to do, and I would cut that.
Okay, are there any other specialists that want to make any other comments? I don't know if Dennis wants to talk anything about wheat that he's seen this week or not.
Mark seems to have a question. Mark, your
Mark, you have
hand
a
is raised.
question?
Actually, not a question. I don't want to interrupt this discussion, but I did want to add the support and congratulations to Mike Staten and appreciation from the soybean growers of the state to put in a career and make such great impacts as he did throughout the state. So thank you, Mike, for your great work, and you will be missed.
Yep.
Thanks, Mark.
There's a comment here. I think someone said last week traveled to Northern Ohio and saw no planters in the field. Why are they not planting early like we do in mid-Michigan? I think that's a good one. I think they have been wet too. I don't think, I think they're probably even better compared to us. My counterpart at Ohio State, she has done a lot of work on the soybean early planting side of things and have seen benefits. I mean, they're a little bit, few extra days compared to folks in mid-Michigan area. So they probably don't need to, hurry things up as much. But I think it's the wetness that's playing a role more than anything else. I think I've heard a lot of folks. Someone actually in Ohio told me that they planted last week of March, even into early April. So I think they are looking into this. And as Mike was saying, at least to extend our planting window so we don't have to deal with the delayed planting, getting our crop in, if nothing else. And soybean plant seems to do okay with, with these non-ideal early season planting conditions that you might not see a yield benefit, but you might actually not see a yield decline, even if you have some loss in stand and going as low as 60, 70K, relatively uniform stand still seems to do the trick. And if we have big gaps, we can go in and interplant instead of replanting the whole thing. So
Someone did ask about if that recent freeze killed insect eggs. You can always wish, but that didn't happen. The eggs, if they overwintered, they were laid someplace protected, like in a stem or, in something. And any insect that was already out, and there were some moths and some other things flying around, they just crept into a crevice and waited it out. So I don't think anything died that I could see except wimpy fruit blossoms or something. So.
And I think Dennis is not on here, but I did walk a couple of plots. I think I had 1 or 2 calls, people asking any impact of this low temperatures that Jeff was talking about on winter wheat. And I don't think I have seen anything as of now. I think we were just on the edge, but not cold enough or long enough to actually cause an injury to the wheat. You might see some like cosmetic damage, some leaf burn and things like that. But I think overall, we probably were okay.
All righty. If that's all the information we need today, I want to thank everyone for your attendance and your participation, and best wishes to Mike Staten in his retirement. So thank you, everyone, and you have a fantastic day. Stay safe out there. Thank you.